Hello everyone, my name is Tim, and today we're going to talk about something really fun I hope for you and me. It's current relays. Current relays are a device like this that are used in fractional horsepower compressors, similar to the ones we see over here, to actually get it started. Now, a current relay has a couple of connections that we need to know about. And the first one is the incoming power. This is my L terminal. That L terminal goes through a set of windings, round, and out of the set of windings, straight to the M, or the main winding, the run winding. But we have another connection over here, which is for my start winding. And a connection over here, which allows me to check my start winding real quick to see, or my contacts for my start winding to see if they actually pull in. If I look at my diagram, we're going to see we have a contact on L1 and L2. Now, in this case we're using 2, but we could use just L2 if we wanted and use this as a common. When these pull in, I'm going to apply power to both my run and my start winding. The run winding is much less resistance than the start winding, so it's going to be easier to go through this winding than through the start winding. So, when I have L1 and L2 energized, it's going to go through L and M of my current relay. As soon as it does that, it's going to apply power to that run winding. Now that run winding is going to not do much of anything except draw a whole lot of current because it can't get that rotor actually spinning without the help of that start winding. So with that high current drawing a locked rotor, what's going to happen is I'm going to close between S1 and 1. Those contacts are going to physically close with that high current. Now I've brought in the start windings with my optional start capacitor to give me that little bit of extra kick if I need it. Again, this is optional. It's going to bring that start winding in because those contacts are physically closed. Now, all of a sudden, the current is going to start to drop because it's physically moving. Now, once the current starts to drop, it's going to open up those set of contacts again and actually drop out the start winding. Okay? Now, to start this start section of this current relay can actually be tested. Physically connect a lead between the start winding connection and that other lead I showed you. And if you look at our meter here, as I shake it back and forth, you'll see it start to move. That's an indicator that set of contacts is actually working. You can also listen to this, and you can actually hear it. So, this is an example of my stationary winding. I'm going to have both a start winding and a run winding in here. The run winding is going to pull in first, draw a huge amount of current, allow that set of contacts to pull in from my current relay, bring in the start set of windings to get this motor actually running. Now if I was to open this up and take a look at what's inside, I'm going to see my L terminal, my run terminal, and over here I've got my start, and then another lead to show me that I physically made a contact between the start and the L. But as you can see, I just have a little connection there. And if I pull this one off, you can see there's the connection point there. And internally, I can see the physical set of contacts that are going to close between these two sets of terminals. If I open it up even further, I can see these set of contacts. I can also see my main lead coming in, and this is the wire that's going to go to my run winding. And you can see that they're just wrapped around wire, just thick wire. So again, these come in various shapes and sizes, not to be confused with contactors or relays. And if I come over here and look, in this circuit right here, I have my current relay. Okay, and I've got my ammeter connected to the start winding. When I energize it, you'll see the current start to come up really hot, and you'll see it back down. That indicates that as soon as I flip the switches, almost instantaneously, because of the high current in the run winding, it's going to pull in the set of contacts and pull that start winding in. Then shortly after that, it's going to drop out and allow to run just on the run winding. As you saw there, the current went up and then went back down, and the noise changed a little bit when it went into start. This validates that those sets of contacts are open. That current that I'm seeing right now is just from my back EMF. So, our current relay, really cool device. Shouldn't be confused with contactors or relays. Shouldn't be confused with a potential relay, which is used in starting circuits as well, which is covered in another video. If we look back at our diagram, our current relay goes by another name, current magnetic relay, or CMR. We have three terminals, L terminal, M, and S. When we close the set of contacts between L1 and L2, we're going to apply power to the run. It's going to draw a high amount of current. That high current is going to pull in the set of contacts between S1 and 1, enabling me to power up my start winding, give that rotor a little bit extra torque to spin it in the right direction. I can use my optional start capacitor to give it even more torque on whatever application that I'm using. Once that current has built up and the motor goes to start, that current will start to go down. When the current starts to go down, the set of contacts will go back to their normally open set position. So current relays, wonderful little device for utilizing, starting for fractional horsepower compressors, quickly identified by the set of windings that are exposed. Thank you very much. I hope you've enjoyed this video. This is Tim out.